Hello, my dear students. Welcome to the session. Continuation of important observations from power electronics concepts. I am discussing power semiconductor devices concepts. In this session, first I am going to starting concept of LC circuit. I would like to discuss LC circuit concept in different cases. First, we have to start with case 1. In case 1, let assume that initial current in the inductor is 0. Initial voltage across the capacitor is also 0. This is the derivation part. For quick revision point of view, we need to concentrate on the derivation. Mainly you have to concentrate final formulas. What is the current through the LC circuit? What is the voltage across the capacitor? These two formulas are very important. If there is no initial current in the inductor, if there is no initial voltage across the capacitor, and this is the expression for current. This is the current through the LC circuit. Current through LC circuit. And through. But condition is, if there is no initial current in the inductor, there is no initial voltage across the capacitor. And one more point you have to remember, these formulas are applicable if the diode is given, even thyristor is also given, these formulas are applicable. Let assume that thyristor is triggered at alpha equal to 0 and switch is closed at t equal to 0. With that assumption, these formulas are applicable for diode case, even thyristor case. Then in the first case, this is the current through the LC circuit. What is the voltage across the capacitor? This is the voltage across the capacitor. This is the instantaneous voltage across the capacitor. But what is the peak voltage across the capacitor? The peak voltage across the capacitor is 2 Vs. And this is the formula for voltage across the inductor. Then what is the observation here? This formula is very important. If there is no initial voltage across the capacitor, then capacitor charged to a maximum voltage of 2 Vs. Now we have the doubt, sir, we are giving the supply voltage Vs, but how the capacitor will charge to 2 Vs? The capacitor is charging to 2 Vs because whatever the energy stored in the inductor, that is transferred to the capacitor. Because of energy stored in the inductor is transferred to the capacitor, there is a rise in voltage across the capacitor. By assumption of there is no initial voltage across the capacitor, it charged to a peak voltage of 2 Vs. These three formulas, these four formulas are very important here, students. But no need to concentrate on the derivation part. What is the current? Vs into square root C by L into sin omega naught t. What is the voltage across the inductor? Vs into cos omega naught t. What is the voltage across the capacitor? This is instantaneous voltage across the capacitor. Vs into 1 minus cos omega naught t. What is the peak voltage across the capacitor? 2 Vs. And one more point you have to remember. In LC circuit, at what value of omega naught t, the voltage across the capacitor is maximum. Angle is pi. Pi radian or 180 degree. At pi radian or 180 degree, voltage across the capacitor is maximum. If the time is asked, we may expect either angle or time. At what time voltage across the capacitor is maximum? At pi root LC. At pi root LC, at t equal to pi root LC seconds, the voltage across the capacitor is maximum. What is omega naught here, friends? Omega naught equal to 1 by root LC. Every observation is very important that you have to concentrate. This is the observation. If there is no initial current in the inductor, there is no initial voltage across the capacitor. Here I told already. In this case, the capacitor charging to a voltage of 2 Vs because whatever the energy stored in the inductor, that is transferred to the capacitor. Then what is the steady state voltage across the diode? At steady state condition, we know that inductor acts as a short circuit. Voltage across the inductor equal to 0 at steady state condition. Capacitor voltage is 2 Vs. Supply voltage is Vs. If supply voltage is Vs, capacitor voltage is 2 Vs, then what is the voltage across the diode? Voltage across the diode equal to Vs minus 2 Vs, that is minus Vs. This point already given. In LC circuit, the capacitor is overcharging because the energy stored in the inductor is transferred to the capacitor. The energy stored in the inductor is transferred to the capacitor. What is the voltage across the diode, students? The voltage across the diode equal to supply voltage minus peak voltage across the capacitor, that equal to minus Vs. That is, at steady state condition, voltage across the diode is minus Vs means the diode is under reverse bias condition. These observations are very important, friends. Then with respect to these observations, these waveforms that I drawn, you please concentrate. I equal to Vs into square root C by L into sin of omega naught is. With this, at what value of omega t the current is maximum? Very important. At omega t equal to pi by 2. We may expect either angle or time also. They will ask the angle or they will ask the time also for any competitive exam. If they ask the angle, at 90 degrees current is maximum. If they ask the time, at pi by 2 root LC, current is maximum. Next, what is this peak value of current? Substitute omega naught equal to pi by 2 here. Sin 91. What is the peak value of current? The peak value of current equal to Vs into square root C by L. This observation is very important to understand the commutation circuits, to understand the commutation methods. In a LC circuit, what is the peak current? This peak current is also called peak commutating current. Why the peak current is also called peak commutating current? Because in commutation circuits, LC elements we are using, those elements are nothing but a commutating elements. That's why whatever the LC circuit peak current is there, that current is also called peak commutating current. Once again I am repeating, why LC circuit is called peak commutating current? Because in commutation methods, L and C elements are used as a commutating elements. Because of this reason, it is also called peak commutating current or commutating current. What is the formula for peak current or peak commutating current? Vs into square root of C by L. Throughout explanation of commutation method, this formula is very important, students. Wherever the LC circuit concept will come, what the peak current expression? Vs into square root C by L. But this formula is applicable with the assumption of there is no initial current in the inductor, there is no initial voltage across the capacitor. All these formulas are with respect to case 1 only. Then this is the current waveform, students. Where the current is maximum at omega t equal to pi by 2 or t equal to pi by 2 root s. Where the current is 0 at pi, omega t equal to pi. Time is pi root LC, at pi root LC. That means in LC circuit, the device conduct how much time? Pi root LC time it will conduct. Very important. In LC circuit, how much angle the device will conduct? 180 degree. If the time is asked, how much time it will conduct? Pi root LC. It conduct with a time of pi root LC. Very important formula that you have to. And this is the capacitor voltage waveform. Capacitor voltage reaches to a peak voltage at omega t equal to pi. At omega t equal to pi, it reaches to the peak voltage. What is the peak voltage across the capacitor? 2 Vs. And this is the voltage across the inductor waveform, students. This waveform is the voltage across the inductor waveform, VL waveform. This is the VC waveform, students. This waveform is the VC waveform. And this waveform is the VL waveform. And what is the voltage across the diode? We know that here the diode is conducting. Diode is conducting. Whenever the capacitor charged to a peak voltage of 2 Vs, supply voltage is Vs. Now what is the voltage across the diode? Voltage across the diode equal to minus Vs. This calculation I given. Finally, what is the voltage across the diode, friends? Voltage across the diode is minus Vs. Then diode is a reverse bias. These are the observations from case 1 that you have to concentrate. Very important observation. Current expression. At what time or at what angle current is maximum? What is the expression for peak current? At what time or what angle? At what angle current is 0? How much angle the device will conduct? How much the capacitor charged to a peak value? 2 Vs. 2 Vs. Why the capacitor is overcharging here? Because of inductor stored, because of energy stored in the inductor is transferred to the capacitor. At that point you have to concentrate. Then case 2. Here case 2 I am giving with the assumption of there is no initial current in the inductor, but let assume that initial voltage across the capacitor is positive and that is the V0. But no need to remember all these derivation parts. Simply remember like this, friends. If the voltage across the capacitor, initial voltage across the capacitor is positive, you subtract from 2 Vs. That gives the peak voltage across the capacitor. How to get the peak voltage across the capacitor? Simply remember like this. If the voltage across the capacitor is positive is given, you subtract from Vs. If the voltage across the capacitor is negative they given, add the V0. Add the initial voltage across the capacitor. Sir, why like this? Because based on this derivation only. See this one. This is the expression for current. Previously, what is the expression for current? Vs into square root of C by L. Now what is the expression for current? Vs minus V0. Vs minus V0. Initial voltage across the capacitor is positive is given. You take minus here. You have to subtract. This is the expression for current. This formula only you have to remember. What is the peak current expression? Initially Vs into square root C by L. Now Vs minus V0. Vs minus V0 into square root C by L. If initial voltage across the capacitor is given, you have to subtract. If positive is given, subtract. Negative is given, add here. Next case that you have to see. This formula important, and this formula also you have to concentrate. What is the peak voltage across the capacitor? Peak voltage across the capacitor is without initial voltage 2 Vs. With initial voltage 2 Vs minus V0. Positive is given, you have to subtract. That only you remember. Remaining no need to concentrate, students. No need to concentrate on the derivation part because the quick revision. For quick revision point of view, these formulas are important. Current expression, peak current expression, peak voltage across the capacitor. But diode conduction time is still it is a pi root LC one. Previous case also pi root LC, here also pi root LC. Simply remember one point. If there is no initial current in the inductor, for any case, the device conduction time is pi root LC only. If the initial current in the inductor is given, then only the diode conduction time will change. The diode conduction time will change. Maximum up to now, most of all the competitive exams, even in gate exam also, by giving the initial current in the inductor, no question. They ask the questions only with the initial voltage across the capacitors. That cases only mainly you have to concentrate. Next, third case, case 3. Initial current in the inductor is 0. Let initial voltage across the capacitor is negative. No need to concentrate on the derivation part. If I told already, if the initial voltage across the capacitor is negative is given, you have to add this. This initial voltage you have to add to Vs. Positive is given, subtracted. Na? Negative is given, you have to add. Then Vs plus V0. This is the instantaneous current expression. Concentrate on the instantaneous current expression. Concentrate on the peak current expression. Concentrate on the peak voltage across the capacitor. And this is the peak current expression. Vs plus V0. Negative is given, plus you take. Vs plus V0. Then what is the diode conduction time? It is a pi root LC only. Then what is the peak voltage across the capacitor? Without initial voltage, what is the peak voltage? 2 Vs. Initial voltage across the negative. Na? If it is a negative, you take plus here. Here you see. If it is a positive, then you take minus here. That's the only difference. This is the case 3 formulas that you have to concentrate. And this is the instantaneous current expression. This formula say instantaneous current expression. Maximum they are asking instantaneous current expression also. Already in gate exam based on these formulas. But they asked without initial voltage across the capacitor. If there is no initial voltage means you take V0 is 0. V0 is 0. Then case 4 is tank circuit. This is also very important. Already question is there in gate exam based on the tank circuit. In a tank circuit, again you have to concentrate. Tank circuit means there is no any supply voltage. This is the case without any supply voltage. Then what is the current expression? Let us assume that initial voltage across the capacitor is V0. Then V0 into square root C by L into sine of omega naught. This is the current expression. What is the peak voltage across the capacitor? Peak voltage across the capacitor is V0 only. There is no any Vs here. Well, if Vs is present, 2 Vs. 2 Vs. If any initial voltage is there, positive is given, 2 Vs minus V0. Negative is given, 2 Vs plus V0. But there is no any supply voltage, sir. That's why, what is the peak voltage across the capacitor here? V0 only. Maximum voltage across the capacitor is V0 only. Here also, device conduction time is pi root LC only. Where the current is maximum? At a time of pi by 2 root LC. Where the current is 0? At a time of pi root LC. That is also same points it is applicable. Finally, what is the voltage across the diode? Minus V0. What is the peak voltage across the capacitor? V0. These formulas. This is in tank circuit. Tank circuit is nothing but it is also LC circuit, but there is no any supply voltage here. Next, case 5. But these cases are not that much of important. These extra cases that I am giving. In case 5, let us assume that initial current in the inductor is I0. Initial voltage across the capacitor is V0. This is as it is. Vs minus, because positive is given. If initial voltage across the capacitor is positive, Vs minus V0 into square root C by L sin omega. But extra what we are getting? Because of this I0 cos omega naught we can get. This is the current expression. But here the diode conduction time is changing. What is the diode conduction time? It is not pi root LC. pi minus theta by omega naught. How to find this theta? Tan inverse b by a. What is this b value? What is this a value, friends? This is the b value. This I naught into cos omega naught is there. This I naught into cos omega naught. This is the b value. This I naught. This is the b value. Not cos omega naught. Only I naught is the b value. Vs minus v naught into square root c by l is there. This is the a value. Substitute here. In this form, we can get theta. Theta we substitute here. Then we can get diode conduction. Here the diode conduction time is different. If I naught is given, diode conduction time is pi minus theta by omega naught. If I naught is not given, then theta becomes 0. Na? Theta becomes 0. Then we can get pi by omega naught. Pi by omega naught. What is omega naught? Omega naught equal to 1 by root LC. Substitute that. But you can get pi root LC. If theta equal to 0. When the theta equal to 0, if I naught is 0. If I naught is given, this is the formula that you have to remember. Concentrate. All these observations are very important for your exam point of view, mainly for gate. Then in this case, what is the peak voltage across the capacitance? Still now, any competitive exam, up to case 4 only it is very important, even for gate point of view also. Remaining cases are not framed, it is expected models only. For this case, what is the peak voltage across the capacitor? Vs plus Vs minus V naught whole square plus I naught into square root L by C whole square. Because I naught is given. Because I naught is given, this expression we can use. Vs plus Vs minus V naught whole square plus I naught into square root L by C with the assumption of initial current in the inductor I naught, initial voltage across the capacitor is positive. If initial voltage across the capacitor is negative, then you have to take the plus here. Here plus. You have to take. Here also plus you take. Vs plus. But I am not. That condition I am leaving for. That condition I am leaving for. Let us assume that IL of 0 equal to I naught, Vc of 0 equal to 0. There is no initial voltage across the capacitor. If there is no initial voltage across the capacitor, then V naught is 0. Vs into square root of C by L into sin omega t. Because of I naught cos omega naught, extra we can get this one. Diode conduction time, device conduction time is pi minus theta by y sir. Because I naught is given. Then this is the peak voltage across the capacitor. Because V naught is 0. V naught is 0. Because initial voltage across the capacitor equal. This is the case 6 student. Next, this is case 7 that you have to concentrate. If the circuit is given like this parallel LC circuit, parallel LC combination it is given. This is the expression for I, V naught into square root C by L into sin omega naught t. What is the voltage across the inductor? That equal to minus Vc. What is the voltage across the capacitor? But these cases are not framed, but you have to remember this case 7 also. Then case 8 students. This is the LC circuit, parallel LC circuit with parallel switch arrangement. Here the series switch arrangement, here the parallel switch arrangement. And in this case, what is the I expression? I naught into cos omega naught t. What is the Vc expression? I naught into square root L by C into sin omega naught t. What is the VL expression? I naught into square root L by C into sin omega naught t. These formulas, whatever the 5 star I am putting now, the stars, that formulas mainly you have to concentrate. This is the different cases of LC circuit. You have to concentrate. Then it is a RLC circuit. This concept you studied even in the network theory also. In RLC circuit, you remember this omega naught formula. Resonating frequency, omega r square plus zeta square, where zeta is the damping ratio. Zeta is the damping ratio. In RLC circuit, what is the damping ratio formula? R by 2L. Then these are the roots, no need to concentrate. This formula is important. This formula is important. Then omega naught equal to square root omega r square plus zeta square. This is omega r is the ringing frequency. This also you have to concentrate in LC circuit. Sorry, in RLC circuit. What is the zeta here? Zeta equal to r by 2L. R by. These points mainly important in RLC circuit. There is a different cases are there. Zeta less than omega naught. Roots are complex and circuit is said to be underdamped. For underdamped RLC circuit, the condition is R square less than 4L by C. This is the underdamped RLC circuit. R square less than 4L by C or zeta less than omega naught. Both are correct. Next, for zeta greater than omega naught, roots are real and circuit is said to be overdamped. In overdamped case, R square is greater than 4L by C with respect to circuit elements also. R square greater than 4L by C. But roots are real and said to be overdamped. Here roots are complex. circuit. This is the current expression and this is the current expression. Maximum we don't expect current expressions. Maximum we have to concentrate. These are the condition for, this is for underdamped, this is for overdamped. What about the roots also you have to concentrate. If zeta equal to omega naught, zeta equal to omega naught means that is here what I given, r square greater than 4l by c, r square equal to 4l by c, r square equal to 4l by c with respect to circuit elements, and roots are equal and circuit is said to be critically damped case, and this is the current expression. Then what is the response for underdamped case? This is the response for underdamped case. This is the response for critically damped case. This is the response for overdamped case. About underdamped, overdamped and critically damped, you studied in the, even in control system also, what is the response of second order system. That points also applicable. That you have to consider. This concept you studied even in the network theory also. Here I given the 3 or 4 models of question that you have to consider. No need to remember the formulas. Just you have to remember the instantaneous current expression. Here this is the case 1 problem. There is no initial voltage across the capacitor. There is no initial current in the inductor. In that case, Vs into square root of C by L into sine of 1 by root LC into T. L value you have to substitute, C value you have to substitute. I am getting the current expression. What is the peak current expression? This is the directly, it is a peak current. If you want to calculate separately, Vs into square root C by L. What is the peak voltage? If there is no initial voltage across the capacitor, it is a 2 Vs. 2 into 100, 2 into 200, 400 volts. What is the diode conduction time? If there is no initial current in the inductor, pi root LC only. What is finally diode voltage? Supply voltage across the diode, supply voltage and peak voltage across the capacitor. What is the supply voltage? 200. Peak voltage across the capacitor is 400. 200 minus 400 minus 200. Next, let initial voltage across the capacitor is positive. This is plus and this is minus, positive. If it is a positive, I told you have to subtract. Minus you have to. Then Vs minus V0. Remaining same. For the peak current, this is the peak current. Or you can calculate Vs minus V0. Extra we are getting this Vs minus V0. Remaining as it is. Then Vcp is actually 2 Vs. Positive is given, you subtract. Actually 2 Vs without any initial voltage. But initial voltage across the capacitor is positive. 2 into 200 minus 20, that we are getting 380. Then what is the diode conduction time, students? Pi root LC. Finally, what is the voltage across the diode? Supply voltage minus peak voltage across the capacitor, that we are getting minus 180 volts. This is the case 2 problem. This is the case 1 problem. And this is the case 3 problem. Initial voltage across the capacitor is negative. If initial voltage across the capacitor is negative, if negative is given, you have to add here. Addition. Vs plus V0. 220 V. This is the peak current. Or separately if you want, Vs plus V0 into square root C by L. For the peak voltage, 2 Vs. Because negative is given, you have to add plus 420 volts. Diode conduction time, pi root LC. Final voltage, what is the voltage across the diode? That is supply voltage minus peak voltage across the capacitor. Supply voltage is how much? 200 volts. Peak voltage across the capacitor, 420. Totally it's minus 220 volts. Then in this case, what is the peak voltage across the capacitor? Peak voltage across the capacitor is 2 into 300. 2 Vs. But initial voltage across the capacitor is 2 Vs, not 2 Vs. This is positive. If it is a positive means you subtract minus 40. 560. Like this we can easily. Maximum they are asking initial, that is the instantaneous current also. That you have to concentrate. And this problem, this is the LC circuit concept. LC circuit problem. LC circuit V0 into square root of C by L. C you know, L you know, you substitute here. Peak current is V0 into square root C by L. Vcp is V0 only. Vd is minus V0. Diode conduction time is 5 milliseconds. Like this you have to calculate. And this also one question that I solved. You please concentrate this one. This is LC values they given, and you have to calculate what is I expression. I equal to V0 into square root C by L into. It is a LC circuit concept, tank circuit concept. There is no any supply voltage here. V0 into square root of C by L into sine of 1 by root LC into T. You have to calculate. This is the current expression. That is option D is the right answer. How to practice that question. Next, very important concept with respect to semiconductor devices concepts, that is commutation methods. One more important topic. Even for commutation methods also, you have to concentrate alternative names. That is also important for theory questions. Applications also very important for theory questions. For each commutation method, there is some formulas are there. That formulas also you have to concentrate, because directly they are asking for formula based questions also. Directly numericals are framing from the formulas. Friends, we know that what is the commutation? The process of turn off of SCR is called commutation. How we can turn off the SCR? To turn off the SCR, we have to apply the reverse voltage and reduce the current below some minimum value of current. That current is called holding current. Then how to turn off these thyristors? To turn off these thyristors, we have to use different methods. That methods are nothing but a commutation methods. One is natural commutation. It is also called class F commutation. Forced commutation, load commutation. The commutation methods are broadly classified into natural commutation, forced commutation, and load commutation. This load commutation is also called self commutation or class A commutation. Self commutation or class A commutation is also called resonant commutation. It's also called resonant commutation. All this I given. Natural commutation. What do you mean by natural commutations? The supply voltage itself is used to turn off the thyristor. That means whatever the supply we are giving for the circuit, by using that supply only we can turn off the thyristor. But this is applicable only for AC supply. If the supply is AC, then only natural commutation is applicable. This natural commutation is also called line commutation or class F commutations. Natural commutation is also called line commutation or class. Alternative names also important. Even applications also important. How to turn off the thyristor in natural commutation? By using supply itself. If you want to turn off the thyristor by using supply itself, what nature of supply is required? AC supply. That's why natural commutation is applicable only for AC supply. Why? Because for every half cycle in AC supply, the supply will reversal, then thyristor will be turned off. That is nothing but a natural commutation. This you have to concentrate. Positive half cycle, device is conducting. Negative half cycle, device is turn off. Again positive half cycle, device is conducting. Negative half cycle, turn off. This type of commutation is called which commutation? Natural commutation. For this case, what the circuit turn off time? This is equal to pi by omega. Circuit turn off time equal to, for natural commutation, let us assume that we are triggering the thyristor at alpha equal to 0, then the circuit turn off time Tc equal to pi by. What do you mean by circuit turn off time? It is the time taken a reverse voltage applied across the device in one cycle. In one cycle, how much time it is applied, how much angle, pi angle, then divide by omega gives the time split. That is the circuit turn off. For this circuit, what is the circuit turn off time? Pi omega. In detail about this circuit turn off time calculation, that we will see in the rectifier's case. What are the applications of the natural commutations? The natural commutation or line commutation mainly used for rectifiers, AC voltage controllers, step down cycloconverters, line commutated inverter. Line commutated inverter is not an inverter circuit, it is a rectifier circuit only. A rectifier alpha greater than 90 degrees. A full wave rectifier, alpha greater than 90 degrees, acts as an inverter. Those inverters are called line commutated inverter. At this point you have to, these are the applications. But where the line commutation is exist, if the supply is AC, then only line commutation is possible. The supply is DC, line commutation is not possible. Then forced commutation. If SCR is turned off by using external circuit, then it is called forced commutation. Forced commutation we can employ for both AC and DC. Then AC case also you can apply forced commutation if you want to turn off the thyristor before reversal of the supply. Even for DC case, we can apply the forced commutation method. But a commutation circuit consists of inductor, capacitor, auxiliary thyristor, center tap transformer, etc. That is, different commutation methods consist of different elements. But generally, which are the commutating elements? Inductor and capacitor are the commutating elements. But in some commutation circuits, only capacitor we are using. But generally, inductor and capacitor is the commutating elements. In some commutation circuits, it consists of center tap transformer also. It consists. In some commutation circuit, we are using saturable reactors also. What are the types of forced commutation? These observations are very important for theory questions. But don't think, sir, you don't expect theory questions from gate point of. Already questions are framed. Based on these alternative names also questions are there in gate exam. This is important. Not only in GATE exam, other competitive exam point of view also, alternative names and applications are very important, students. Class B commutation, it is also called current commutation or resonant commutation. Class B commutation, it is also called current commutation or resonant pulse commutation. Resonant pulse commutation. Well, the name is resonant pulse commutation. Applications of class B commutation is current commutated chopper and Morgan chopper. In current commutated chopper and Morgan chopper, we are using this class B commutation. It is also called current commutation or resonant pulse commutation. Class C commutation is also called complementary commutation. Where we can use this class C commutation? Parallel inverter and current source inverter. Applications are important. Alternative names are also important. You have to consider. Class D commutation is also called impulse commutation or voltage commutation. Applications are voltage commutated chopper and all these are which commutation methods? Forced commutation method. Class C commutation is also called external pulse commutation. If you don't have any practical application, you have to do it. Class D commutation, impulse or voltage commutation. Class C commutation, complementary commutation. Class B commutation, that is the current to commutation or resonant pulse commutation. These methods are forced commutation. And there is one more commutation, load commutation. It is also called self commutation, or it is a class A commutation or resonant commutation. It is also called not resonant pulse, it is a resonant commutation. Also called resonant commutation. So of the following is the resonant commutation. Class A commutation is the resonant commutation. If the SCR is turned off by making the load current is zero, then it is called load commutation. What do you mean by load commutation? Why the name is given as a load commutation? In this commutation method, by making the load current is zero, the thyristors are turned off. That's why it is called load commutation. Where you can use this load commutation? Series inverter. In series inverter, we are using this load commutation. Here I am solving one question. This is a matching question. One is application point of view, another one is alternative names point of view. Line commutation. Which is the line commutation? Which is the line commutation, friends? Line commutation is the class F commutation. That's why F is the matching. Which is the load commutation? Load commutation is the class A commutation or self commutation or resonant commutation. A is the matching. Which is the impulse commutation? Class D commutation or voltage commutation is the impulse commutation. Which is the resonant pulse commutation? Class B commutation is the resonant pulse commutation. Class B commutation is the resonant pulse commutation. Then matching is B. Their matching is D or D. Okay? Matching is. That is impulse commutation is which is the impulse commutation, sir? Class D commutation. C. Matching is. Pulse commutation is which one? Class D commutation. Resonant pulse commutation is which one? Class B commutation. B is matching. External pulse commutation. Class E commutation. E is the matching. Complementary commutation. Complementary commutation is the class E commutation. Then which is the matching? D is the matching. Is the matching? D is the matching. Class E commutation. Like this way. Line commutation is which one? Class F. Load commutation is class A. That is A is matching. Impulse commutation is class D or voltage C. Class D or voltage commutation. That is C is matching. Resonant pulse commutation is resonant pulse. Resonant pulse is current commutation. Class B is matching. External pulse commutation is class E. E is matching. Complementary commutation is class E commutation. Class E is which one? D. D is the matching. Like this you have to make the. This is based on alternative. And this question is matching question based on the application point. Where we can use class A commutation. Class A commutation is used in series inverters. D is matching. Where we can use class B commutation. Current commutated chopper. That is B is matching. Where we can use class C commutation. Class C commutation is parallel inverter. That is E is matching. Class D commutation, students. Voltage commutated chopper. C is matching. Class F commutation. Class F commutation is a natural commutation. That is we are using in the rectifiers. Like this we have to match the question. This is a matching question. Now we'll see in detail about each commutation method. Some important formulas. I told already. Class A commutation is also called self commutation or it is also called resonant commutation. It is also called class A commutation or self commutation or resonant commutation. That is nothing but a load commutation. What do you mean by load commutation? Load commutation is also called class A commutation or self commutation or resonant commutation. By making the load current is 0, the thyristor is turned on. That means to make the load current is 0, the circuit must be underdamped. This is important. For load commutation, load commutation, circuit must be underdamped. Circuit must be underdamped circuit. Then only load commutation is exist. Circuit is underdamped means that is R square less than 4L by C. R square less than 4L by R square less than. For load commutation, circuit must be underdamped. Then R square is less than 4L. For underdamped RLC circuit, it must be capacitive nature, Xc greater than XL. Underdamped RLC circuit, Xc greater than. That is for load commutation, Xc greater than XL. Xc greater than XL means capacitive nature. Then which power factor? Leading power factor. Case of leading power factor. This is important. Then you have to select this L and C elements. This is the load. And this is the load parameter is R. You have to select this L and C parameters in such a way that R square less than 4L by C. Then the circuit is a load commutation circuit. Then it is underdamped. If R square greater than 4L by C, that is overdamped circuit. R square greater than 4L by C, that is over. But here the circuit must be underdamped circuit. If you select the underdamped circuit, naturally the load current is 0. Naturally the load current is 0. That is based on L and C elements. If this current is 0, if the load current is 0, friends, the load current is 0, what is the current through the thyristor? The current through the thyristor is also 0, then thyristor will be turned off. This type of commutation is called class A commutation or load commutation or self commutation or resonant commutation. The circuit must be what nature? Underdamped. What power factor it is operating? Leading power. These points mainly you have to concentrate for load commutation. Next, class B commutation. Class B commutation is also called current commutation or resonant pulse commutation. Current commutation or resonant pulse commutation. Class B commutation. This is the class B commutation circuit. This is the class B commutation circuit. But very important points that you have to remember here. No need to discuss the operation. Very important point. This is the main thyristor. This is called main thyristor. This is called auxiliary thyristor. What is the T1 here, friends? T1 is the main thyristor. Main thyristor. What is the TA here? TA equal to auxiliary thyristor. TA is the auxiliary thyristor. Then very important points that you have to remember. First one is what is the peak current through the main SCR? Peak current through main SCR. What is the peak current through the main SCR? In thyristor. It carries only load current in class B commutation. That is peak current through the main thyristor IT1P equal to I01 load current. What is the peak current through the auxiliary thyristor? It carries the LC circuit current. Peak current through auxiliary thyristor. Peak current. That ITAP equal to carries only which one? LC circuit current. What is the peak current in LC circuit? Is Vs into square root C by. What is the peak current through the diode? This diode. Peak current through diode. Peak current. These formulas are important. Peak current through diode. A peak current through the diode, that IDP equal to, this is the LC circuit and is also equal to load current. I0, if they given I0, that is correct, or it is also correct. Peak current through the diode equal to Vs into square root of C by. Any formula it is given, both are correct. Peak current through the diode, it is asked two cases here. If they given the load current, that is also correct. If they given the only LC circuit current, that is also correct. Only LC circuit current they given, that is also correct. Both the formulas are correct here, that you have to concentrate. Then One more important formula. What is the circuit turn-off time? What is the circuit turn-off time? TC equal to, this is the circuit turn-off time. Circuit turn-off time. Circuit turn-off time TC equal to pi minus 2 theta by omega naught. Pi minus 2 theta by omega. What is theta here? Theta equal to sine inverse. How to write? Theta equal to sine inverse I naught by IP. This value of theta equal to, you have to write sine inverse I naught or 1 by x. Sine inverse simply how to write 1 by x. That x value I will give. You have to remember like this, sine inverse 1 by x. But what is x here? X equal to, you have to write ICP by I naught. X equal to ICP by I naught. ICP is nothing but a peak commutating current. This is the peak commutating current. Vs into square root C by L. Vs into square root C by L. Every formula is important, but you have to. What is the peak voltage across the capacitor? Peak voltage across the capacitor. The peak voltage across the capacitor, VCP equal to, how to remember, VCP equal to Vs plus I naught into square root L by C. Not C by L, it is I naught into square root L by C. This is also very important formula. Peak voltage across the capacitor, Vs plus I naught into square root L. There is a design formulas are there for inductor and capacitor also. What is the design formula for commutating inductor? Commutating inductor formulas. Commutating inductor L equal to, this is the design formula, directly you have to remember, is L equal to Vs into Tc by xi naught into pi minus 2 into sine inverse. If they ask any design formula, like the sine inverse 1 by x, this total is L square. I am repeating this, L equal to Vs into Tc, where Tc is the circuit turn-off time. Vs into Tc by xi naught. X already you know, xi naught. This you have to calculate, x equal to ICP by a naught. Xi naught into, clearly I am writing here, if you want, this you have to write xi naught into pi minus 2 into sine inverse 1 by x. Sine inverse. This is sine inverse. Sine inverse 1 by x. This is multiplication. This is the design formula for commutating. What is the design formula for commutating capacitors? Commutating capacitor. The commutating capacitor C equal to, how to write, xi naught Tc by Vs into pi minus same 2 into sine inverse 1 by x. 2 into sine inverse 1 by x. Repeating this, pi minus Vs into pi minus 2 into sine inverse 1 by x. Xi naught Tc. Here what is Tc? Tc is the circuit. These formulas mainly how to. These are the design formulas. What is the design formula for commutating inductor? This is the design. What is the design formula for commutating capacitor? The design. Till now, no question in GATE exam based on these formulas, but in ESC descriptive already questions are there based on this formula. These are the formulas mainly how to concentrate on class B commutation. Class B commutation is also called current commutation or resonant pulse commutation. Already application of this commutation I given. This is used in current commutated chopper and also Morgan chopper. Next, class C commutation. Class C commutation is also called complementary commutation. Why the name is given as a complementary commutation? Turn on of one thyristor will turn off the another thyristor. If you turn on one thyristor, the another thyristor will be turned off. For example, when I turn on the T1, T2 will be turned on. When I turn on the T2, T1 will be turned on. That's why name is given as a complementary commutation. This class C commutation mainly used in parallel inverter and even current source inverter. Here mainly how to remember what is the peak current through T1 thyristor. Peak current through T1. How to remember this peak current through T1 thyristor, that is IT1P equal to the peak current through the T1 thyristor Vs into 1 by R1 plus 2 by R2. Vs into 1 by R1 plus 2 by R2. What the peak current through T2 thyristor? Peak current through T2 thyristor. Peak current through T2 thyristor. The peak current through T2 thyristor is peak current through T2 thyristor IT2P is equal to Vs into 2 by R1 plus 1 by R2. 2 by R1 plus 1 by R2. This you have to remember. What is the circuit turn off time of T1 thyristor? For T1 thyristor, circuit turn off time. Circuit turn off time. For T1 thyristor circuit turn off time, TC1 equal to R1C into ln of 2. For T2 thyristor, what the circuit turn off time? TC2 equal to R2C into ln of 2. If R1 equal to R2 equal to R, if R1 equal to R2 equal to R, both the resistances are equal, then you have to apply circuit turn off time equal to RC into ln of 2. Based on this formula, already gate question is there, repeated question. For your exam also, it may be repeated, ready to remember. But sometimes they don't give circuit turn off time directly, they will give the device turn off. This is note point. For all the commutation method, this formula is applicable. Then if TQ is a device turn off time, TQ is a device turn off time. I already explained in switching characteristics, turn off characters. Then circuit turn off time TC equal to some safety factor. They will give the safety factor also. Safety factor into TQ. Safety factor into TQ. What is TQ here? TQ is the device turn off time. The safety factor into TQ. That you have to remember. This is the circuit turn off time equal to some safety factor into device turn. This is about the class C commutation. The next one is a class D commutation method. This class D commutation where T1 is the main thyristor, T1 is the main thyristor, TA is the auxiliary thyristor. This method of commutation is also called voltage commutation. An auxiliary thyristor TA is used for turning off the main thyristor T1. Even in this circuit also, this auxiliary thyristor is used to turn off this main thyristor. Auxiliary thyristor is to turn off the main thyristor. Here also same. This type of commutation is also known as auxiliary commutation. It is also called parallel capacitor commutation. Why the name is given as a parallel capacitor commutation? Because by using a negative voltage across the capacitor, the thyristor will be turned off. Or by connecting the capacitor parallel to the main thyristor, the thyristor will be turned off. That's why it is called parallel capacitor commutation. It is also called impulse commutation, that I told already. It is also called impulse commutation. So called impulse commutation. Pulse. But another name for this one, this is the impulse commutation. Then what are the formulas that you have to concentrate? Peak current through the capacitor is, that is the LC circuit current, Vs into square root C by. What is the peak current through the main thyristor? IP plus I0. I0 is the load current. What is I0 here? Average value of load current. Average value of load. I0 is the average value of load. Even class B commutation also, I given I0 now. This is also peak current through the main thyristor is I0 is average load current. Average load current. See the difference here. Here main thyristor is carrying only I0 current. But in the case of class D commutation, main thyristor is carrying two currents, peak current and peak current. Peak current means LC circuit current. Peak current is the LC circuit current. This is the peak current, LC circuit, and also load current. That's why Whatever the thyristor we are using in the class D commutation, that is high rating thyristor we are using. Then what is the peak current to auxiliary thyristor? It's only load current. What is the circuit turn off time of main thyristor, students? CVS by naught. What is the circuit turn off time of auxiliary thyristor? The circuit turn off time of auxiliary thyristor is pi by 2. You can write 1 by omega naught. Omega naught is pi. Omega naught is 1 by root LC. That is pi by 2 root LC. Next, what is the minimum on period of main thyristor? Minimum on period of main thyristor. On period of main thyristor. Main thyristor. The minimum on period of main thyristor is pi root LC. This is circuit turn off time of main thyristor. The circuit turn off time of main thyristor is also equal to device turn off time of main thyristor also you have to consider. That is CVS by I naught. And if you want to define what is the effective duty cycle, in this case effective duty cycle. Effective duty cycle. Effective, actually this will repeat in the choppers also. Effective duty cycle, that is D dash equal to you have to write T on dash by T. What is the T on dash? Is T on dash equal to T on plus 2TC. 2TC is nothing but a TC already you know. This is the circuit term. 2 CVS by naught. T on plus 2 CVS by naught. Yes. It takes the circuit term, 2 time intervals. That's why 2TC we are getting 2 into CVS by naught. What is the T on here? T on equal to pi root x. This is effective duty cycle. Generally for choppers point of view, these formulas are important. The discussion of the choppers also I will give this formula. Then once you know the effective duty cycle, this T on dash is effective on period. Effective on period of main thyristor. Effective. If they ask the effective on period, that you have to calculate. Once you know this, what is the average output voltage? An average output, if you want to calculate, output equal to, then this is equal to D dash into Vs. One more important point you have to remember, what the peak instantaneous voltage across the load. This is one of the drawback of class D commutation. Peak instantaneous voltage or peak inverse voltage. Peak instantaneous voltage across the load. Voltage across. If any freewheeling diode is present, that is the peak instantaneous voltage across freewheeling diode also, across the load. These points will repeat in the choppers also. Equal to 2 Vs. Peak instantaneous voltage across the load is these 2 Vs. These formulas are very important. Circuit turn off time. Already question is framed in gate exam. That is CVS by naught. Then what is the circuit turn off time of the auxiliary thyristor? Pi by 2 omega naught, or pi by 2 root LC. What is the circuit turn off time of the main thyristor? CVS by naught. What is the minimum on period of the main thyristor? Pi root LC. All these points you have to concentrate with respect to class D. But class C commutation, we don't have any formula. Simply you remember, in this class C commutation, we are using external supply. That's why external pulse commutation. This is the external supply. This we are using external supply. In class D commutation, we are using class E commutation. External pulse commutation, external supply. And in this commutation, the capacitor charged to a voltage of 2V1. The capacitor, if this external supply is V1, capacitor charged to a voltage of 2V1. Capacitor charged to a voltage of 2V1. Charged to a voltage of 2. This circuit you have to remember what this circuit it represents. If the question is asked, then it indicates that is class C commutation. But one of the main drawback of this commutation is to turn off the one thyristor. Extra we are using 2 thyristors, one extra supply. The costly. No? Just to turn off of one thyristor, 2 thyristors, one capacitor, and extra supply also we are using. That is the class C commutation or external pulse. These are the different commutation methods with respect to thyristor. One more important topic in power semiconductor devices concepts, that is the firing circuits of SC. This is directly given in the gate syllabus. They mention the gate syllabus firing circuits, SCR firing circuits. SCR firing circuits, one is the resistance firing circuits are there. In that resistance firing circuit, one is R firing circuit and RC firing circuit. One is a R firing circuit, R firing circuit, RC firing circuit, RC firing, R firing circuit, RC firing circuit, and one more is a UJT firing circuit. One more is a UJT firing circuit. R firing circuit, RC firing circuit, and UJT firing circuit. These three firing circuits are. This is the R firing circuit. In R firing circuit, mainly what is the purpose of this diode, what is the purpose of R1 resistance, what is the purpose of this diode, all these points I given. Please go through this one. But that is not important here. These observations are very, formulas are important. But till now, no questions in any competitive exam with respect to formulas point of view. But you have to concentrate formulas because directly it is given in the gate syllabus. And these are the conditions also that you have to concentrate with respect to alpha. What are the statements I give? Please go through that statement. For quick revision point of view, directly I am giving the formulas. Then main important relation is this one. That is, in the case of R firing circuit, how to calculate the firing angle. This formula you have to remember. This is the 5-star gunshot form. In R firing circuit, sine inverse VGT by VCP. That is VGP equal to Vm into R by R1 plus R2 plus R. What is the VGP? Vm into R by R1 plus R2 plus R. What is alpha? This is the exact formula for alpha. That is sine inverse VGT into this VGP formula that I substituted here. This VGP is there. Na? This value is substituted. This is the simplified one. But no need to remember simplified one. Just to remember this formula and this VGP value. Separately calculate VGP and substitute here. VGT given. Then you calculate the firing angle. Yeah, this is the firing angle control. Firing angle control in R firing circuit. R firing angle control in R firing circuit that you have to consider. Next, what is the RC firing circuit? In RC firing circuit, there is again half wave firing circuit and full wave firing circuit. The second method, RC firing circuit. RC firing circuit. In RC firing circuits again, there is a two types of firing circuit. One is half wave, RC half wave firing circuit. RC half wave firing circuit. And RC full wave firing circuit. RC full wave firing circuit. That you have to concentrate. Then in RC half wave firing circuit, this condition, what the power in the range of power frequencies, RC for zero output voltage is given by RC greater than or equal to 1.3T by 2, that is nearly equal to 4 by 1. This range you have to remember. What the range of firing angle control? The firing angle can never be 0 and 180 degrees. That means it is controlled between 0 and 180 degrees. But alpha is controlled between 0 degrees to 180 degrees. But in R firing circuits, in R firing circuit, this is important. In R firing circuit, the firing angle is controlled. Alpha is controlled 0 degrees to 90 degrees. 0 degrees to 90 degrees. That is in R firing circuit, the firing angle is controlled 0 to 180. 0 to 90. In RC firing circuit, it is a 0 to 180. R firing circuit 0 to 90. RC firing circuit 0 to 180. It may be half wave or full wave. It is a 0 to 180 degrees. It is controlled. And these conditions also you have to remember. And Vs is greater than or equal to R into IGT plus Vc. But no questions till now it is framed. But just to concentrate what are the points that I given. You please go through this point. Then RC full wave firing circuit. For RC full wave circuit, firing circuit, what is the empirical relation? This empirical relation is important. But the range of firing angle control. Range of firing angle also 0 to 180 degrees it is controlled. The full wave. It's RC circuit means it is 0 to 180 degree control. Then what are the limitations of R firing circuits and RC firing circuits? Even prolonged pulses. This is very important main drawback of this R firing circuit and RC firing circuits is we are not generating the sharp pulses. It is a prolonged pulses, very large width pulses generating that leads to the more power dissipation. R and RC triggering circuits cannot be used for automatic or feedback control system. R firing circuit is used only for 0 to 90 degrees control only. But RC firing circuit no problem, 0 to 180. But range of firing angle is generally 0 to 181. That is possible with RC. But problem with R firing circuit and RC, we are generating the prolonged pulses. It is not a sharp pulse. To overcome this drawback only, we are going for UJT firing circuit. Before going to starting the UJT firing circuit, there's some important points you have to remember for UJT. UJT stands for uni-junction transistor. This is the structure of the UJT. And this is the equivalent circuit of the UJT. This is the structure of the UJT. Then VA B1 equal to, this is the formula. This is VA B1 formula. That's VA B1 equal to eta VB, where eta is the standoff ratio that you have to concentrate. Then what is the PE formula or peak voltage formula? Peak voltage formula equal to eta VBB plus VD. This point C is called the valley point. Whatever this point is now, valley point. And IV are the, where VV is the valley voltage, IV are the valley current corresponding to emitter potential and current. And this is the formula for emitter current formula. This is the peak voltage formula. Here see, this reason is called negative reason. Why the name is given as a negative reason? In this reason, if the current is increasing but voltage is falling, current is increasing, that's why UJT is having negative resistance characters. Important. UJT having negative resistance character. I told already. Even tunnel diode is also negative resistance character 6. Gun diode is also negative resistance character. UJT is having negative resistance character. Negative resistance characters. That point mainly concerned. Having the negative resistance. Where eta is the standoff ratio. Eta is the standoff. That points mainly. Then how to, that is the between point B and C, emitter voltage VE falls as IE increases. UJT therefore exhibits a negative resistance between these 2 points. Then how to calculate the current, the value point, the current is given by, that is VV by RB1. Value point current also called holding current keeps the UJTs on. That is minimum current you have to maintain, the UJT keeps the on state. If the current is below this value current, then UJT will be turned off. The UJT will be turned off. This observation is also very important. You have to concentrate. And these relations also that you have to concentrate. What is VC equal to V equal to VB? Actually, this formula I already given. Eta VBB plus V. That is VV plus, in terms of value voltage, in terms of base voltage, how to write it? Is the peak voltage. Whenever it is peak voltage, then that PN junction is breakdown. Then it comes into the on state. It comes into the on. And it is UJT is used as an oscillator. Then in UJT firing circuit, we can generate the very sharp pulses. UJT circuit, very sharp pulses are generated like this. Very sharp. That whatever the drawback is there in R firing circuit and RC firing circuit, that can be overcome here. That is a UJT as a relaxation oscillator. This indicates UJT as a relaxation. It generates the sweep signal or sawtooth wave. That is, UJT is used as a relaxation option. UJT as a relaxation oscillator. Because it generates the sweep signal or sawtooth wave. This is also called sweep signal. By using the UJT, you can generate the sweep signal. That's why it is used as a relaxation oscillator. Then what is the firing angle for this case? In case T is taken as the time period of the output pulse duration, then the value of firing angle is given by, this is the formula for UJT firing circuit. For UJT firing circuit, this is the firing angle. And these are the design formula for R2, R max and R minimum. This formula is also very important during solving of the problem. But this is very important. This is very important that you have to concentrate. From this, it is asking that what the frequency or time period of frequency, and then synchronized usage triggering. This also called ramp trigger. Synchronized usage triggering. This also called ramp triggering. Why the name is given as a ramp triggering? Method of controlling the output power by varying the charging resistor R is called ramp control. By varying the charging resistor R, then controlling of output is done. That's why it is called the ramp control technique. Here the time is equal to alpha by omega. That you see in the waveform. This is the time is equal to alpha by omega. Then in case R is reduced so that VC reaches UJT threshold voltage. All these points not that much of important that you have to concentrate. But mainly this formula is only all that points I give. You have to concentrate. This is the ramp pedestal trigger. PPD is the pedestal voltage. But still now in any competitive exam, no questions based on these formulas. But only this is expected. Just to please go through the formula. This is simplified. This is about the ramp pedestal circuit. Firing circuit of triac. That is a firing circuit of triac is provided by using diac. This point only remember. Firing circuit of triac. Firing circuit of triac is provided using diac. This observation is important concept. But no need of any operation, all this, we don't have any formulas also. Next, one more important concept with respect to thyristor, that is the power semiconductor devices concepts. What are the ratings of the SCR ratings? This is also important. I am not giving all the ratings here. Just names mainly you have to consider. SCR rating. In SCR ratings, voltage ratings. In voltage ratings, these are the forward voltage ratings. And these are the reverse voltage ratings. PDRM stands for peak repetitive to forward blocking voltage. There is some terminology is there. According to that terminology only the names are given. This M indicate the peak in forward direction. In forward direction, M indicate the peak. R indicate the repetitive. D indicate the forward blocking. That is peak repetitive to forward blocking voltage. M stands for peak. W stands for working forward blocking voltage. VDSM, peak surge. S indicate the surge or non-repetitive to forward blocking voltage. VRWM. These are 4, 5, 6 is in reverse case. In reverse case, W indicates the working, R indicate the reverse. Here R indicate the repetitive, but this is the reverse voltage. These are reverse bias condition. This is for reverse bias condition. These three voltages are reverse bias condition, and these three voltages are forward bias condition. Forward bias condition. That you have to remember. As names are you have to concentrate. And one observation here, in forward bias condition, in forward blocking, in forward bias, which is the highest voltage? VB0. Forward breakdown voltage is the highest. Next, VDSM. VDSM is peak non-repetitive to or peak surge voltage is next. Next one is VDR. Lowest voltage is the VDR in forward direction. Highest voltage VB0. In reverse blocking, in reverse bias, which is the highest voltage? VBR. Reverse breakdown voltage is highest voltage. The next one is VRSM. VRSM is highest voltage. Least is VRRM. The names also I given. Please go through this one. There is some terminology is there. What the R stands for in forward direction? What is the M stands for in forward direction? D stands. In forward direction, M is peak. R is repetitive. D is forward blocking. But in the case of reverse direction, M is as it is peak. W is working. Forward, reverse, W is working. But in reverse direction, R is reverse voltage. But here R is repetitive. This is important. These points you have to. S is surge or non-repetitive. And this formula also very important that you have to concentrate. What is the voltage safety factor? From this we can expect the problem also. Voltage safety factor equal to That is the peak repetitive reverse voltage or peak inverse voltage also you take. This is also equal to voltage safety factor equal to peak inverse voltage by root 2 into RMS value of input. Root 2 into RMS. And what is the range of voltage safety factor? The range of voltage safety factor is 2 to 3. Then what is the finger voltage? I already explained about the finger voltage. Even though gate supply is connected, to turn on the SCR, a minimum forward voltage is required. That minimum forward voltage is nothing but a finger voltage. Mainly for voltage safety, in voltage ratings, voltage safety factor is important. But all the ratings are not clearly, sorry, in detail I am not clear. In detail I am not explaining, not required. Surge current rating is important. Surge current rating is important. Please go through these points. But problem is very important with this case. Surge current rating point of view, you have to concentrate these formulas. For surge current, you have to concentrate this formula. This is very important. No need to concentrate on the theory points. Concentrate on this one. This is the time for 1 half cycle of supply frequency. I equal to 1 cycle surge current rating. ISB equal to sub-cycle surge current rating. T equal duration of sub-cycle surge. Then what is the I square T rating? In I square T rating mainly used for selection of the protective elements. Protective equipment of thyristor you have to use mainly for fuse selection. Fuse is selected based on the I square T rating. And this is the I square T rating formula that you have to consider. This is also very important. Yes, friends. Then this problem only you practice. Maximum, this is the expected gunshot 5-star model. Still now not asked in gate exam, but this model framed in the different competitive exam. Yeah, this is the expected formula. Expected question. Already formula I given. This is the question based on the surge current rating. Question based on the surge current. They will ask the I square T current rating. They will ask the what the surge current rating current also. Yeah, these two calculations are very important. Direct this question only we can expect. So that you have to concentrate. That is about the what exactly different ratings of the different ratings of the. Students, with this, with respect to power semiconductor devices concept, that is the first chapter. First, power semiconductor devices concepts. I discussed, I given various concepts. What are the important observations from various concepts, starting from different types of devices, different types of switches, how to draw the ideal characteristics of switches, how to find the conduction losses, how to find the switching losses, power diode observations, thyristor construction observations, SCR static VI characteristics observation, SCR turn-on methods observation that I given. Then two transistor analysis also I given. All these observations that I given. Two transistor analysis. After that I given the dynamic characteristics. Dynamic characteristics are nothing but a switching characteristics. But the turn-on characteristics observation, turn-off characteristics, gate characteristics observation, protection circuit and snubber circuit observation. And one more important concept after protection circuit that I given, heating and cooling circuit, series and parallel connection observations that I given. Series and parallel connection, what is the that is the string efficiency for series connected SCRs, string efficiency for parallel connected SCRs that I find. That is a string efficiency case. What is the static equalizing circuit, dynamic equalizing circuit, what are the observations from parallel connection, all these points that I given. After completing the parallel connection, a series connection, then I given the what exactly concept of LC circuit. In this session I given concept of LC circuit, and I given the very important concepts, that is the commutation methods formulas, mainly you have to concentrate, and firing circuit. Still now not asked, but that is there in gate syllabus. That's why what are the points I given, please go through that points. That is the firing circuits. Finally, ratings of it. With this, with respect to power semiconductor devices, the quick revision of power electronics is complete only for first chapter. Next, I am going to starting chapter 2, that is the rectifiers. Rectifiers quick revision, important observations from diode rectifiers, single phase diode rectifier, three phase diode rectifier, single phase control rectifier, three phase control rectifier. The next session that we will continue. This is about the session.